Today we have a very important topic we'll be discussing in mathematics. We have, under mathematics, we'll be dealing with a topic in cycle or geometry. And that topic has to do with a theorem. Now this theorem says the angle that an arc of a cycle subtends at the center is twice that which it subtained at any point on the remaining part of the word circumference. Now, to show that the angle an arc subtained at the center is twice the one subtained at any part of the circumference, let's quickly look at what is an arc. Now, if you have a cycle like this, now let's say from this point to this point, if I call this A and I call this B, from this point to this point is an arc. Now, from this point to this point is also called an arc. So here now I have a major arc and a minor arc. Now we are saying that if this is the center of the cycle O and this arc AB subtend an angle at the center. Now this theorem is saying that if you also have another angle at any part of the circumference that is subtained by this same arc AB, that the one at the center is twice the one at the circumference, and that is just what we want to show today. And then we have now in mathematics, usually when you want to prove, you have to be given certain parameters which you will now use. Now the first one is I've been given a cycle APB with center O. Now the second step is to prove that AOB, angle AOB, that is the angle at the center, is twice APB. Now the third step or procedure is the construction stage. Now here you join PO, that is this point PO, and produce it to any point Q. So as you see on the board, PO has been joined and it is produced toward Q. Now the proof. Now for us to prove that this angle AOB is twice APB. Now let's go. What is the first thing we need to do here? The first thing we need to do here is to also understand that OA, line OA is equal to OP. And what is the reason? Radar. Now, in a cycle, you all agree with me that in a cycle, now, every line from any point on the circumference to the center is a radius. Now, if I draw another line from this center to any part of the circumference, it's also a radius. So, this and this are equal, as long as it is within the same cycle. If I draw another line from this point to any part of the circumference, it's also equal. So, all the three, 1, 2, 3 are what? Equal. So you see, your OA and OP are what? Equal. So if they are equal, it means that therefore A triangle or angle AOP is an isosceles. Is an isosceles what? Triangle. And for an isosceles triangle is a triangle whereby two sides are equal. Now, if two sides are equal in an isosceles triangle, if two sides are equal, it means the base angles are what? Equal. So, and here, since this is an isosceles triangle, it means my x1 is equal to what? x2. that is base angles of isosceles what? Triangle. Now, that also means that therefore, y1 is equals to what? y2. Same reason. Now, x1 is equals to what? x2. And y1 is equals to what? y2. And we also know that if you have but A, O, Q is equals to what? x1 plus x2. Now, there is a theorem that says the exterior angle of a triangle is equal to the opposite interior angle. So if this is, for example, this is x and this is A, B, that theorem says x is equals to what? A plus B. And there's a proof for that. Now, here, it means A, O, Q is equal to x1 plus what? x2. Reason, exterior angles of a triangle. Now, the same thing with B, O, Q. BOQ is also equal to what? y1 plus y2. Same reason. And also x1 is equals to x2, which has been established. And y1 is equals to what? y2. So therefore, I have A, O, Q plus B, O, Q is equals to, that is 2x2 plus 2y2. Therefore, A, O, B is equals to 2x plus y. Now, as you can see, I've been able to prove that AOB is twice what? x2 plus y2. Now, you can see clearly that the angle at the center is twice the one at the what? Circumference. So, in a nutshell, it also means the steps you've seen, the steps are what is required. So, if you are given something like this, for instance, if you are given something like this, and you are to show, probably let's say you have, this is given to you as 40, and this is, you are asked to find this. Now, since this angle, this and this, are subtended by the same arc, it means the one at the center is going to be twice the one at the circumference. So if this one at the center is 40, the one at the circumference will be what? 20. So that is just the essence of the whole proof. So if you have these similar questions or an exercise on this, you can just apply these principles and you get your answers. So with this, I believe you will check it out. Thank you very much.